Welcome everyone to this session, Solving Big Problems with Query Store Hints. My name is Dennis Torres and I'll be talking about this great new feature, Query Store Hints in SQL Server. This is me. I'm a data platform MVP, trainer, leader of the MultiData platform user group. I live in Malta, and you can see my contacts. It will be a pleasure to stay in touch. So, a bit about the MultiData platform user group. So we have a Facebook page, Facebook group, Meetup, WhatsApp, Twitter, all this for the group members to be together, to reach each other, to ask questions, technical questions to each other, and so on. So feel free to reach us. This month, on August 23, we will be returning with our in-person technical sessions. We will have a technical session at the Microsoft Innovation Center at the Sky Parks. The session will be about Microsoft Fabric, enabling data mesh with Microsoft Fabric. So you can register for the session and it will be a great session. So, our agenda today. Before getting to the point about query store hints, we need to talk about parameterized queries and really understand what the parameterized queries are. Then we talk about parameter sniffing, which is a very common problem to solve using query store hints. Query store hints can be used for many different problems, but a very common is the parameter sniffing. Then we'll see the demonstration about query store hints and talk a bit about the future. So, parameterized queries. Let's start with a demonstration about parameterization of queries in SQL Server. So, here I have SQL Server 2022 with two databases, AdventureWorks and Wide World Importers. So, let me open this first example. I use AdventureWorks and will work with Query Store. One first detail to notice about Query Store is the default configuration when we enable Query Store. The query capture mode is defined as auto. What this means? This means that Query Store will only capture queries that it considers really important, really heavy for the system. Other queries, small queries, it will be dismissed. For this demonstration purpose, the capture mode auto doesn't work very well for us because our queries will not end up not being captured. So let me exactly demonstrate this. So I enable the query capture mode as auto, which is the default. Let me empty the query store, set query store clear, and check the capture query text. No, nothing captured. Then let me execute two queries. One query, another query, and check the query text again, and nothing was captured because the capture mode is auto. If I would like to capture everything that my database receives, I need to change the query capture mode to all instead of auto. But I'm doing this because the demonstration. If you decide to do this in a production database, you need to be very careful. because by doing so, you are increasing the amount of queries that Query Store will be capturing. You will be increasing the activity on the database related to Query Store. So you need to be very careful if you decide to change this configuration. Okay, let me clear the Query Store again. It was already empty, and then let's test these two queries. Let's execute them, checking the execution plan. The first query has index scan execution plan, and there is one detail very interesting. Both queries are more or less the same, just changing the value. And the query plan, when displayed on SSMS, gives us the impression that the value would become parameterized. See, at 1 the value was replaced, so it gives us the feeling that the value would be parameterized. So the first query is executing with a clustered index scan, and the second query is executing with an index seek. Now let's check the text capture for these queries, and what we will discover is that the queries were not parameterized. These queries were not parameterized. You can see the queries with their specific values captured inside Query Store. So SQL Server decided to not parameterize these queries. Yes, it was a SQL Server decision. Let's try this other one. On the product category table, I'm filtering by the product category ID. Let's try this other one. I don't have anything with the category ID 10, or probably category ID 15 not as well, okay? But what's important is the query. We see the same image as if the query is parameterized, but now if I check the query text, I see this query was really parameterized. This query was really parameterized. So some queries SQL Server decides to parameterize, to replace the value with a parameter, so the query plan in the cache can be reused, while other queries SQL Server decides to not parameterize, and this is SQL Server decision. Yes, that's it. There are some clues in relation to the decision why it decides about one and not another. For example, the product category ID is the primary key of the table. The other one is not. So there are some clues you can identify in relation why SQL Server decides to parameterize one query and decides to not parameterize another query. Of course, we can change this behavior. On the purpose of the database, among the options, there is one option called parameterization. So there is one option here called parameterization, which is specified as simple. If you change this option to parameterization forced, all queries will be parameterized. Is this good or is this bad? In fact, I'll show you that parameterizing every query is not a good idea. This is not a good idea at all. You should keep a balance on the parameterization of your queries. Another example in relation to parameterization is this one. When we create a batch using SQL variables, this query is parameterized by the code. The code forces the parameterization of this query. Clustered index scan and clustered index scan. So the code forces the parameterization of this query. If I check the queries in query store, this one, the product category is already here, but let's see the last ones here. Here is the select from big products with list price parameterized as price. The code forced the parameterization. Okay. Now that I understand in relation to the parameterization, we understand a bit about the parameterization, let's get back to our slides. So, parameterization of the query brings a problem which is called parameter sniffing. We need to talk a bit more about this problem. First, we need to review some very basic concepts. The execution plan, the compilation of the query creates the execution plan. Every time the query is compiled, an execution plan is created and stored in the query plan cache. The execution plan is parameterized or can be parameterized or not. It depends on the query. Some queries may have the execution plan parameterized, some queries may haven't. The plan is stored in the query plan cache and the plan is reused for multiple parameter values. So, the parameterization is good to produce a plan reuse. That plan will be reused for multiple parameter values, and in this way, we will expend less memory on the server in relation to the query plan cache. We will be able to store more plans in the query plan cache, different plans in the query plan cache. And we will not expend processor time by compiling the query. The compilation process spends processor time, and that's not good. So, this is the good side of parameterization, but what could be a bad side of parameterization of a query? The bad side is related to this question. Is the execution plan good enough for any parameter value for this query? The execution plan that is created when the query is compiled is good enough to support any value for the parameter or not. What defines this? How would we know? Well, it depends on the distribution of the values along the column that we are using on our predicate, in our query. For example, if I'm filtering by supplier ID, let's imagine that I'm filtering by supplier ID. Are the values evenly distributed? So, if I query this table by supplier 2 or by supplier 4, is the number of the records that will be returned similar? If the number of records is similar, this means the value is evenly distributed. It doesn't mind which supplier I try to retrieve. The number of records retrieved will be very similar. In a situation like this, when the values are evenly distributed, the parameterization works great, and a single plan can support any value that arrives for this query, because the amount of records returned will be the same. However, if the values are not evenly distributed, what happens? In this example, you will see an example where the suppliers 4 and 5 have a completely different number of records. These two suppliers have a completely different number of records. This means that the query plan, which supports the supplier ID 2, for example, will not work well for the supplier ID 4 and 5. And the opposite also happens. The plan that works well for the supplier ID 4 and 5 will not work well for the supplier ID 2. So, in this case, the data is not evenly distributed, and parameterizing a query over the supplier ID on this example is a bad idea. It will have bad results. Then comes parameter sniffing. Parameter sniffing is the natural result when we parameterize a query over a column which is not evenly distributed. What happens? Exactly this example. Select from stock items where supplier ID equal 2. The query plan will be built to support this value, the value 2. The query plan will be built to support the value 2 and only this value. So the plan will be created and stored in the query plan cache. Then when a second query arrives with a different value, value 4, what will happen? The same plan for the value 2 will be reused for the value 4. But the plan is not good for the value 4. In fact, the plan is absolutely terrible for the value 4. And will have a terrible performance. This is called parameter sniffing because the plan is created based on the parameter value of the first execution which arrives on the server. So it's sniffing the parameter and creating the plan according to this parameter. So this problem is called parameter sniffing, and if the value is not evenly distributed, that will be a bad plan. What can go wrong? The type of join can go wrong. We have multiple types of joins which appear in the query plan. Nested loops, hash joins, for example, the type of join can be wrong. Microsoft tried to solve or work around this problem, create a feature called adaptive join. Adaptive join is a special operator that goes in the query plan and can dynamically choose the type of join in the middle of the execution of the query. So the same plan could work for parameter values that need different types of join. That's an improvement, but this was not the only problem caused by parameter sniffing. Memory grant can go wrong. For one parameter value, a small amount of memory may be enough. For another parameter value, a huge amount of memory would be needed. Again, trying to work around this scenario, Microsoft created a feature called memory grant feedback. So Microsoft created the memory grant feedback to work around this problem. And what the memory grant feedback does, when a query is executed and after execution SQL Server notices the memory grant for that query was not enough, or if it was too much, a feedback is created. So the plan is like annotated to change the memory grant on the next execution, not on the execution that just happened, already happened. But for the next execution, the memory grant can be changed. This is a small solution for the problem, But if we get very intense parameter sniffing problems, this will not solve the problem. For example, imagine that one execution needs a huge amount of memory, the next one a small amount, the next one a huge amount, the next one a small amount. This is what I'm calling an intense parameter sniffing problem. In this case, the memory grant feedback needs that the feedback is constant and it stops after repeating 32 times. It just stops. It just stops giving feedback on that way. So it doesn't completely solve the parameter sniffing problem, only maybe minimize light parameter sniffing problems. Index scan, index seek, the type of index query that will be used, if it will use a scan or a seek to query the data. And the wrong choice can completely change the query performance. So these are possible problems that the parameter sniff can cause. And all these problems, when going wrong on a query plan execution, can extremely affect the performance of a query. The performance of a query can be extremely affected by this. So let's see an example about parameter sniffing. Let's get back to our SQL Server. To make some comparisons, I will set the statistics time on and the statistics IO on. Then I'll be clearing the procedure cache and query store frequently. Let's check these first two executions, one and the second one. They are basically the same query with different values over the table big product. So the first query, let's see the actual execution plan, executes and use a clustered index scan. So this first query is using a clustered index scan. This second query is also using a clustered index scan. Let's take a note of the timing and IO used by this query. This, what we just saw, is consistent with my explanation. This means on the first execution of the query plan was compiled and stored in the cache. And the second execution of the query, we used that plan. So this is consistent with what I explained. Not really, not much, not exactly. Let's clear everything again. If this were true, if I reverse the order of the parameters, I should get a different execution plan. So I should get here a different execution plan. But that's not true. I still get a clustered index scan. And the second one, it still gets a clustered index scan. Is this something good? No, not really something good, but it's a behavior when we use a batch and we use variables to parameterize a query in a batch. Which behavior is this? The behavior is that the plan is not created according to the value of the variable. It's really escaping the idea of the parameter sniffing. but it's not created based on the value. It's like an optimization for unknown, for a parameter that is unknown. So it gets a plan that would work more or less independent of the parameter used. There is a better plan that this 9.99 value could be using, but since in this format of batch it makes an optimization for unknown, it never gets used. Let's try something different now. I'll create a store procedure called list product by price and parameterize the store procedure. We will see something very different when using a store procedure in this scenario. Let me clear again. And I will start exactly with the execution of the price with the value 9.99. So I will execute this one, and the execution plan contains an index seek. Because in the case of a store procedure, the parameter sniffing works. And really creates the plan according to the parameter value passed to the procedure. And the plan was created using an index seek. Okay. So let's take a look on the elapsed time, logical reads, and compare. The original one had 600 logical reads. The new one has 200 logical reads. And this was the first execution of the procedure, so it had the compilation of the procedure together. That's why the elapsed time was even a bit higher, because it had the compilation of the procedure. The second one, on the other hand, this one should be using the cluster index scan. But the first plan was already compiled and is in the cache. So this second one will reuse the plan from the first one. So what we see, this plan is using the same index seek for this other value, which was used for the 9.99, and it's not good. How can we know that it's not good? By making the comparison. For example, the logical reads. See the logical reads? 1249 logical reads, when the usual for this plan would be 605, around the 605, if it were using the clustered index scan. But since it's not using the clustered index scan, it creates this problem. We just saw this problem with the plan we use. Let's see the same problem again with the reverse order of the values. Let me clear the cache, execute this stop procedure, generating the clustered index scan, which we know generates a number of logical reads around 600. We know that. Then let's execute with the second value. And the plan for the second value will be reusing the plan of the first value. That's the idea of the parameter sniffing, to reuse the plan, but we are exactly seeing a situation where this idea is not so good. 605 is not that bad, but we know for experience that could be way better. 202 if it were using the correct plan. It could be 202 if it were using the correct plan. Let's see an example. We just checked this example with the stop procedure and saw the parameter sniffing happening. So the first value used is the plan which will be used for the second value. But just a few minutes ago I talked about how the batch using variables use an optimization for unknown. So it uses a generic plan. Let's see the solution for this kind of batch using variables first. And the solution here is to apply a query hint in the query. A query hint telling that we would like always to recompile this query. We would like to always recompile it. So let's see the first one. So the first one uses the clustered index scan. And let's check the second one. And the second one will be using the index seek. So clustered index scan and index seek. And now let's see the same effect with the stop procedures. Applying with recompile on the execute statement, this is one of the options. It's possible that you know other options, such as applying with recompile on the procedure definition. That's possible as well. So let's see this example. The first one uses the clustered index scan, and the second one uses the clustered index seek. So we are seeing that a query hint can solve the problem related to parameter sniffing. But let's talk more about the problems related to query hint and the application of query hints. Let's get back to our PowerPoint. So, a question that I already posed for all of you before: should we parameterize all the queries? The example of parameter sniffing shows that we shouldn't. If we don't parameterize, we suffer with lots of ad hoc queries and recompilations. Queries arriving only on the server and being recompiled. And if we parameterize everything, we suffer with parameter sniffing. Usually parameter sniffing is worse than the recompilation problem, so we try to not force too much the parameterization. And the point is that we need to keep a balance in relation to parameterization. We need to keep a balance related to this. So let's talk about the parameterized queries. Parameterization forces to parameterize everything. I mentioned this while making the demonstration, but we should not enable this because the parameter is sniffing. Concatenated SQL is not parameterized. If you try to concatenate SQL in an application to make the SQL arrive in SQL Server, this is not a parameterized query, but you have a way bigger problem, because you shouldn't be concatenating SQL. Then the problem is not performance anymore, it's a security problem. You have a security problem if you are concatenating SQL. What happens on applications when you use object relationship mapping, ORM, like Entity Framework and Hibernate and others, is that these tools on the application side, they use a special procedure called SP execute SQL. You don't even see this on the application code. You don't build this in the application code. The object that you use to access the database builds this for you, making the queries parameterizable. So they execute the queries through this procedure to make them parameterizable. And the store procedures are parameterized by default. So a bit more about the example I was talking about, concatenating SQL, for example. On the application, you could make a string and concatenate with a value. When this arrives to SQL Server, this would not be parameterized. But this is absolutely wrong, because this opens your application to a security issue called SQL injection. And you should never allow this to happen. You should never allow SQL injection to happen. So you should avoid this at all costs. So the correct method is to specify a parameter and use your code methods. Entity Framework has methods for this, ADO.NET has methods for this, and so on, to define the value of this parameter, and this will be transformed in the execution of the SP execute SQL in SQL Server. This is the correct form to build the SQL. Basic solutions for parameter sniffing. Possible solutions. Apply with recompile for a store procedure. Yes, I mentioned that and I exemplified that. I exemplified this. What should not be done is when the developers consider the problem too difficult to identify. Will this cause parameter sniffing or will this not cause parameter sniffing? The developers consider the problem so difficult to identify, they decide, let's put with recompile on every store procedure. Then you are unbalancing the problem. You are avoiding parameter sniffing, but you are creating a lot of consumption in relation to CPU due to the recompilation that will happen. So the with recompile should be used only when needed, when really needed. Option recompile query hint. Adaptive joins helps. We talked about this before. Memory grant feedback helps. We talked about this before. They are not full solution, but they help. Okay. So, demo with parameter sniffing basic solution. In fact, we just saw the with recompile, just saw the demonstration. So let's move ahead and talk about query hints. So before talking about query store hints, let's talk about query hints in general. They are used to foster behavior when creating the query plan. The option recompile is an example. They force one specific behavior, usually fix specific performance issues. There are a few usual scenarios for query hints, and there are some notes against their use. Important about query hints and the notes against their use. Limits the query optimizer analysis, so that query will always arrive to the server with a hint in it. So it limits the optimizer. What happens if the data that you have, the amount of data you have, changes? What happens if the kind of data you have changes? So the optimizer is limited by the hint to choose some specific behavior and cannot change. So it's not flexible to changes. And it should be used with caution exactly because it's not flexible to changes and requires changes in the source application. the query is coming from the source application. So if you need to apply a hint in a query, you need to change the source application. These are the problems related to query hints. What if you could apply a query hint on the server level instead on the application level? If you could apply a query hint on the server level and make that when that query arrives on the server, the hint is applied, you could easily monitor for changes in your environment and decide to disable that hint or change that hint, for example. That's what query store hints provide. The ability to apply query hints on the server level and not on the application level, with no need to change any application code to apply the query hint. So apply a query hint on the server. No change to the source application, the hint is persisted in query store. Easier to monitor and adapt using query store data. You can check the query store data to monitor how your queries are performing and adapt. It's supported in Azure SQL and SQL Server 2022. So, query store hints are supported in these two SQLs, Azure SQL and SQL Server 2022. Common scenarios, parameter sniffing is a very common scenario. That's why we talked so much about parameter sniffing until now. And memory grant. Fixing memory grants for a query is also a common scenario. Besides that, there are specific optimizations which may be needed for some queries, and you still can apply the hint on the server level. So, let's see this working. Let's see a demonstration about this. Let's get back to our SQL Server. So, let's check the text of the queries that we have here. So, we have this one, which is our query parameterizer, checking list price by at price. So query text ID is 1. So let's discover the query ID, which probably is 1 as well. Then I will apply the query store hint. At the moment I have no query store hint applied. Check that we have a new DMV, query store query hints. So at the moment we have no query hint applied. Then I will apply a query hint option recompile. That's it. Now let's test the result by executing these stop procedures and executing these stop procedures without using any with recompile, just executing and checking the actual query plan. .99 use the index seek and the other one use the index scan, because the option recompile was applied for these queries. I can check the plan, the plans that the query ID 1 has. So we can see the query ID 1 has two plans, one using index seek and the other one using a clustered index scan. We can use the query store runtime stats to evaluate the execution of these plans. These plans, plan ID 1 and plan ID 4, I can evaluate values like standard deviation, standard CPU time. I will not go deep on this, but I'm showing that you can recover these values, evaluate them, and decide if the query is still in need of your query hint. So you have the possibility to use the data in Query Store to analyze the evolution of your environment. But the plan that we checked on the first query, it comes as text. I can use a convert to XML to get the plan as an XML. So I could see the plan itself. If I click on the plan, I see one is a clustered index scan and the other one is an index seek. So one is a clustered index scan and the other one is an index seek. Okay, that's it. We have these two plans and we applied query hints, but which plan is using which query hint? One possible method to discover is joining the tables. We can make a join with some DMVs in Query Store to bring back the information about which query hint is being used by which plan. So if we make this join, we get the information that these plans are using the option recompile query hint. So these plans are using the option recompile query hint. That's good, but that's not totally true. And to illustrate how that's not totally true, I will show how to change the query hint. Let's just change the query hint to optimize for unknown. After applying the optimize for unknown, let's check in details the query plans that we have. So let's see then in more details. And as you can see, it shows like if the optimize for unknown is being used by these plans. Is this true? No, of course not. Of course this is not true. Because these plans were already here when I just applied the optimize for unknown. So this is not true at all. It's fake. The only thing true in this statement is that on the next executions of these queries, the optimize for unknown will be used, but the old plans are not using it. They are not using the optimize for unknown. So we need to be very careful in relation to these queries using the joins of Query Store DMVs, because they can bring false information. And what can we do to discover the real information? We can go directly inside the plan, this plan for example, and check the properties window. In the properties window, we may find here which query hint was used for the compilation of this plan. This plan used the option recompile query hint. I can check the other plan as well, but it's interesting because the option recompile doesn't appear in the other plan. It will not be present in the other plan. it will be present only in the second one. I will explain why in a moment. But is this the only way? Manually discover this information? No. We can do this in another way by using XML queries to extract the information from inside the plan. So I can use an XML query to gather the joins to extract information from inside the plan. And then it shows the current query hint applied to these plans and the query hint really used to compile these plans. But then we face again that one of these plans has a null as a query hint. This is a bit strange because we applied the option recompile. What's happening? Why it's in this way? Well, let's try to remember the sequence. First, the query had to be in query store. If the query was in query store, there was a plan in query store. And only after this, we applied the hint option recompile. Only after one plan was already in query store and not using the option recompile. But wasn't that recompiled again? The point is that even using the hint, if the compilation result is the same as the plan which is already stored, the compilation result is just not saved. So it's possible in many situations that we will face one old plan with a new query hint, because although the option recompiled was applied to it, it resulted in the same thing. So it was not saved, never saved again, and never hashed the usage of the option recompile. This happened. It's a bit complex detail, but it happens. The closest way possible to discover what this plan was using is to check the date, the last execution date of this plan. We can add here the information about the last plan execution date, the last date and time when the plan was executed, and try to remember what query hint we had applied at that time. Couldn't we retrieve a date from the query hints? No. The creation of the query hint doesn't store a date. So we can't compare the execution date with the time the query hint was created. This we can't do. So we are seeing that the query store hints are absolutely great because they allow us to solve performance problems on the server side. And solving performance problems on the server side is something absolutely great. But they are very tricky to manage. When we start trying to retrieve which hint was applied to which plan, this can become a bit tricky to manage. Let's get back to our PowerPoint. And let's talk a bit about the future. Now that we discovered all these great features related to query store hints, let's talk a bit about the future. Technology related to SQL Server 2022. SQL Server 2022 brought many query optimization technologies, and some of these technologies are based on the query store hint, especially the CE feedback, cardinality estimator feedback. Cardinality estimator is the SQL Server component that makes the estimation of the number of rows which a query will return, and based on this estimation, makes some decisions about how that query should execute. The problem is that in this line of decisions, there are many shortcuts the cardinality estimator needs to take. Sometimes they are good, sometimes they are not. So, in SQL Server 2022, there is the concept of feedback for the cardinality estimator. What this means? If a query using one feature of cardinality estimator doesn't perform well, cardinality estimator can create a feedback defining that next time let's change the way we apply the cardinality estimator over this query. And how this feedback is applied? Using query store hints. So what I'm highlighting here is that new and more intelligent query optimization features are using the query store hints. Query store hints is becoming a foundation for new features. That's a point exemplified by cardinality estimator feedback. And we also have parameter sensitive plan optimization, also known as PSP. PSP is absolutely great to help us solve parameter sniffing problems. Let's talk a bit more about PSP, parameter sensitive plan optimization. It's the possibility to have multiple plans for the same query in the plan cache. Whoa! This is a great solution for parameter sniffing, because the problem for parameter sniffing is to reuse the same plan for everything. What if we can have multiple plans? That's the point. If it doesn't completely solve parameter sniffing, at least reduce a lot. Let's see an example demonstration about the PSP. So, the example of PSP I will execute with a different database, wide world importers. So I move to wide world importers, clear the environment. Then I have a stop procedure, get stock items by supplier. I will execute with the parameter 2, using the parameter 2, which leads to an index seek, and then using the parameter 4, which leads to, it takes a bit longer to execute. See, the data is unevenly distributed. Supplier 4 has way more rows than supplier 2. Exactly the typical problem of parameter sniffing. So it takes way longer to execute. That's it. It took 51 seconds to execute using a parallel execution plan with a clustered index scan. And note, each execution uses a different plan. Like if the parameter sniffing is already solved. If I make an XML query inside the query plan cache, I will discover that the same query has different plans. So the same query has different plans. One plan using the clustered index scan, and a different plan using the index seek. So each query has a different plan. I will not go deep about how the PSP works because I have a recorded video in my YouTube channel especially about PSP. You can find the other video there as well. So this gives you an idea about how PSP is powerful to solve the parameter sniffing problem. So here are my contacts. Thank you very much for attending this session, and it will be a pleasure to stay in touch. You can reach me for any questions you may have. Thank you very much.